but definitely have your notes if you want to. So, quiz number 3. Given that fact, the callers of radio stations must have 4 letters. The first letter must be a K or a W. How many call station letters can be made if repetitions are not allowed? All right, so whenever you get a problem that is a how many is a counting problem. We call those counting problems because you're counting how many there are. So whenever you get a how many problem, then you know it's this 4.4 thing, which is going to be the fundamental counting principle, right? You had decisions. Here, how many choices am I making? 4 choices. And you're going to multiply the probabilities. Hang on. Now, the thing about it is that sometimes you have to do the extra step of dividing. When does that occur? We'll talk about how to figure that out and sort those out. But generally speaking, all the rest of them, whenever you have a how many, you've got to figure out how many choices you're making. I would just draw lines for each choice we have, and then figure out how many options go in each choice. So, how many options do you guys think for the first choice?
2.
Well, the first letter has to be a K or a W. 2. Right? So, 2. Now, repetitions are not allowed. In other words, once I use that K or that W, I can't use it again. So if I pick a K, I can't use the K again. If I pick a W, I can't use the W again. But if I pick a K, I can use a W. How many letters are there in the alphabet? 26. So how many options for the next spot?
5.
And then after I use that letter, how many options for the next spot?
4.
And the next spot. Kat, do you have a question?
Can we get our pens?
I'm sorry?
Can we get our pens?
Oh, we're going to do the pens at break. So since no one, like only one person finished like kind of beforehand, then at break time I'll let everybody come up and grab a pen. Make sure they're not you. Okay, so what do you guys get? What's the answer? 410. That seems too low. Great. 27,600. Perfect. Excellent. Okay. Next problem. Factorial is all positive numbers. We take all the positive numbers from 1 up to that number and you multiply them. It's a number of ways of arranging that many items. Right? Because if I'm arranging 3 items, for example, I have 3 options for the first spot, I have 2 options for the second spot, and I have 1 option for the last spot. Right? So it's a how many when you're arranging. So here, how many ways can that be lined up on yourself? If you haven't done it before, I'll take 15 seconds now and do it now if you didn't do it before. In other words, I'm using all of them. So I have 9 trophies. That means I have 9 spots on my shelf. I'm going to multiply them all. How many options for the first spot? 9. Yep, I have all 9. And then after I pick that one, then how many options for the second spot?
8.
The next spot? Next spot?
6.
Then?
5.
Yep. And then 4, 3. Good. So I don't know what that answer was. Can I make an answer? 5,040? No. Cal, what'd you get?
3,062,000.
I'm sorry, what's it again?
362,088.
88?
No, 8.
Like 80, yeah, okay. 880? Is that right? Is that good?
Yeah.
Okay, perfect. Good? All right. Now, permutation, it's really just, permutation is really just fundamental accounting principle. The only difference is, it's just one case of it. So you could just use a fundamental accounting principle, it's totally fine. But we call things a permutation when you cannot reuse items. So, for example, like the PIN number, you can reuse items, right? You can use 000 again. But here, once you use an item, you can't use it again. So think about it as you have a pool of items you're picking from. Once you pick an item, you can't pick from it again. So the letter thing that we did earlier was sort of like number one, did I give you, I didn't do the parts of one, did I? Okay, so, right, so let's go back. I gotta go back a little bit and talk about quiz number one. Oh, I didn't do quiz number one yet. Okay, that's fine, my bad. All right, so if you can reuse items, then that's just fundamental accounting principle always. But if you cannot reuse items, then if order matters, it's a permutation. So what would you do? Well, you just figure out how many spots you have. Like here I'm picking 3 items, right? Top 3. So I've got 3 spots. And then figure out how many options you have for the first spot, the second spot, and the third spot. I like to think about permutation as you start from n. So here I have 8 items, 8 horses. I start from n, and I multiply. I'm going to pick 3 of them, so I'm going to multiply down 3 spots. 8, 7, 6. That's the easiest way of thinking of it. Yeah.
This might sound a little silly, but do you know, or like, does n have to be bigger than r?
Yes.
Okay.
Because r is how many you're picking.
Okay.
So I can't have 3 cats and pick 4.
That makes sense. Okay.
Yeah, no, that was a good question. You just have to kind of think it through.
Yeah.
So quiz number 1. How many ways can we arrange the letters in the word decagon? All right, so I'm using all of them, right? So here I have 7 letters. If I'm going to use all 7 of them, I need to have 7 spots. Starting with 7 options for the first spot, 6 for the next, 5 for the next, then 4, then 3, then 2, then 1, right? So I'm not going to about you guys yet, but I'll figure you guys can multiply, that's fine. How many different 4-letter permutations can be made if I'm only using 4 letters from here? So I'm picking 4, then draw 4 spaces. So that'd be my first suggestion. Is when you do this, if you're picking 4 items or choosing 4 items, just draw 4 spots. If you're picking 3 items, draw 3 spots. Then, how many options for the first spot? 7. Next spot? 6. 5, and then 4. Good? That one is 20 times 42. 840. It's easier. All right, what if you can reuse letters? So I'm picking 4 spots. On the exam, it'll be clear. I'll tell you how many. So I'm picking 4 spots, but I can reuse letters. Now, how many options for the first spot? Options for the second spot? 7. Next spot? And the last one? Right, so it could be Z, D, 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 right? So that's, everybody kind of on board with that part? Okay. Okay, now, so all those are pretty much straightforward. It's the same sort of concept. This one is a little twist. If order doesn't matter, then I need to take all these duplicates. Remember, these 6 items are all duplicates of each other. So I'm here to 10. So this really just counts as 1 item. So it's really 1 here, 1, 2, 3, 4 different groups. How do we get that? Well, we do the permutation like we normally do. You have 4 times 3 times 2. But then we need to divide up the number of duplicates we have. In other words, how many things are in each group. So, how many things are in each group? Well, there's 3 items that you're picking. So it's going to be 3 factorial. How many ways can you arrange 3 items? So in other words, if I'm going to do a combination, you start from, I don't care who, has anybody ever gone to a horse race? you can make a bet on to show. So you pick the top 3 horses that are going to come in first, second, and third in any order. And it doesn't matter which one comes in first, second, or third, just those top 3. So I just need those top 3 to come in. It doesn't matter what order. So I'm picking 3. I got for first place, 8 horses, 8 options. Second place, 7. Third place, 6. But since order doesn't matter, I need to divide out the duplicates, the number of ways of arranging those 3 horses that I picked. How many ways can I arrange those 3 horses? 3 times 2 times 1. And you'll see that they kind of match up 1 for each one of these spots. So it makes it really kind of convenient. You'll end up with 42 in this case. So that's the only thing that's different from the rest of them. And the difference is you have the extra step of dividing out. How do you know the difference between when when order matters and when order doesn't matter? That's the tricky part, right? So the best thing that I've seen is I had a student explain it as, she thinks of them as all being in a bin. So you pick all these items, and you've got this bin. Now, when I pick them, do I put them in a different spot in the bin, and that's where they stay? Or do they all roll around this bin, and they can roll around wherever they want? So she thinks that if you pick up something and you say, you go there, you go there, you go there, then order matters. But if you're like, okay, you, and they just kind of roll around in the bin, and it doesn't matter where they are, then order does not matter. So here, I picked 3 horses. I picked, I don't know, Scarlet Fever, and I pick Roman Candle, and I pick Jonas's Holiday. I don't know. These 3 horses. And I don't care what order they come in. Right? They can come in, I don't care, as long as those are the 3 horses that come in first, second, and third, it doesn't matter what order they come in. Then order doesn't matter. If I pick 3 students to be chaperones on a trip, order doesn't matter. But if I say, okay, the first student I pick, they're going to check the students off as they come in. The second person that I pick, they're going to pick up all the lunches. The third person I pick, they're going to, I don't know, make sure that all the students have got all their paperwork done for the field trips. Then order matters, because they're doing different jobs. Does that make sense? If I pick 3 cats, and I say the first cat I pick, I'm gonna name that cat Mrs. Muffins. I'm gonna name the second cat Walter. Did you ever see the Walter the Cat commercial over the summer? The Olympics? None of you guys saw the Walter the Cat commercial? Oh my gosh. Okay, no worries. Tomorrow, if anyone comes tomorrow, I'll show you guys tomorrow. And the third cat I pick, we'll call him Tuxedo, right? Then, does it matter what order you pick him in? Yes, because they're going to get a different name based upon what order they're picked in. Does that kind of make sense? But if I say I'm just going to pick 3 cats and they're going to be nameless, then order doesn't matter. That's the difference. Is that sort of making kind of more sense? If I'm just going to pick 3 cats and they're just here and I'm not going to name you guys, you're just going to be 3 cats. I'm going to take you home. Then order doesn't matter because there's no difference between them. Okay, I hope that's okay. I get no expression from your faces. All I see are masks. All right. So this is my example I did last class, right? Flower types. How many is she picking? 4. I don't say that order matters, so it doesn't seem necessarily. I don't say that they're going in different spots, so order doesn't matter, which means that I'm going to pick 4 of them. How many options for the first? 9, then 8, then, and then, since order doesn't matter, you divide by 4 times 3 times 2 times 1, because there's 4 of them. Everybody all right, that part? You can use your calculator. You can also simplify it ahead of time, so 3 and 2 make 6. 4 comes out of 8, so that makes 2, so that's 62 times 3. 126. Yeah.
So on the test, if like one of these questions came up, could we write like 9C4 and then do equals, or would you want to see this written out like that?
I want to see these numbers written out.
Okay.
So you cannot just put, such a great question. Maddie said, can I just say 9C4 equals 126? You will get half credit if you write 9C4 equals 126. I want to know what you multiplied. Is everybody clear on that? Let me say it one more time. If you just write 9C4 equals 126, you will get half credit because you haven't shown me your work on this one. Especially on chapter 4.4, I need to know exactly what you multiplied and divided. Yeah.
So on my notes, I wrote that you wrote an alternate way to do it where we did not do that. It was like the NPR and then above the R to the, okay.
Right.
We can do that too on the exam, or do we have to do it that way?
No, you could do that if you're familiar with the other way, which is, but then that's a lot more work. So that would be, that is saying doing this. 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, times 1, divided by R, so it'd be divided by 5 times 4 times 3 times 2 times 1 times 4 times 3 times 2 times 1. So that's what that says. And once you cancel these guys out, then you get the same thing that I got up here.
Okay.
Yeah.
Thank you.
I thought, I'm just confused on that part, because I thought NPR was you start with N and then multiply down.
Yep, this is NCR. So this is, you're right, that's up, this is NCR. 9C4. Yeah. All right. So this is your quiz number 4. Do people need another 30 seconds for these, or everyone has them down? And you guys all have them? Yeah. Okay, so we'll go through these. You're picking 8, so you have 8 slots. Or 1. And I'm going to start with how many for the first spot?
10.
Next spot? 9. Next?
8, 7, 6, 5, 4.
Great. But does order matter? If I'm picking, if I go to the store and I pick 8 videotape to rent, does it matter what order I pick them in? No. So I need to divide by. I picked 8, so I divide by 8 factorial. Now this is a classic spot where you're definitely going to want to cancel out the ones that are in common, right? So 6 above and 6 below cancel out, 5 above, 5 below. And then you'll end up with 10 times 9 divided by 2. So that's 45. Do you need to show me all these numbers being multiplied? Yes. 100%. Because number 5, how many ways can you award first, second, and third from a group of 7 contestants? Does first and second, does it matter what place you come in?
Yes.
Okay, so first of all, you're picking 3. Start with 7, 6, 5. Order matters, so you just leave it like that. 210. Right. Does it matter whether you come in first or second?
Yeah.
Yes, it matters. All right. Okay. Are people feeling okay with the difference between these two and how to tell the difference between which problem it is?
Can you explain it one more time?
Yeah. So the last one is just the regular one we have. It's just normal. Order matters, you just multiply the differences. The top one is this odd case where if order doesn't matter. So if order doesn't matter, then you need to divide the duplicates. So that's kind of when order doesn't matter. And again, if you think back to like a bin with balls rolling around in it, that's my friend called, my other student called chaos, right? They're all rolling around wherever. So that's why it's a C combination. So that C is the one where you divide out the duplicates. Chaos is when you divide out the duplicates. You have the extra step. Maybe Andrea has some tips on that. You guys can consult.
I always think of it as chaos. There's just way more numbers there now. It's just like
Okay, yeah, so,
Like, if it was in order, I know I just put them in order and then multiply them. If it was something that was no order matters, there's a lot more numbers I needed to do, I had to start. Like that kind of like went off in my head.
it's more chaos because you have numbers on the bottom and the top, you have twice as many
Yeah.
numbers because you have to divide out stuff too.
Way more chaotic.
Yeah.
For me to look at, so
Yeah.
that's how I was.
Yeah, more numbers, more to do stuff with. Right, so, like I said before, people asked, how do you know when it's a permutation or a combination? Aha. So, what is a permutation or a combination? It's when you have one pool that you're drawing from and you can't reuse items. So we're not talking about different pools. Right, the shirts, socks, pants, you guys remember that one? That's not one pool. I'm just taking one pair of pants, done with that pool. A different pool, one shirt, done with that one, right? It's not that I've got shirts, I'm taking one shirt, then a second shirt, then a third shirt, you know what I mean? So that's how they're different, is when it's just one pool we're drawing from, and you can't reuse items. Second thing is, how do you know it's permutation versus combination? When you select each one, right, are you putting it in a specific place, or assigning it something to do? Like if you're picking a team. If I'm just picking a team and I say, I'm the soccer coach, we used to have tryouts, I'm going to pick a team of 16 players. Done. You pick them, order doesn't matter. But if I say, I'm going to pick someone to be a sweeper, I'm going to pick someone to be a goalkeeper, I'm going to pick someone to be a left half, a left fullback, a right half, stopper, right? If you're picking them for a specific position, then all of a sudden order matters. See that you can. But yeah, if it's just going into the giant bin or mixing with others, then that's the chaos. That's when you have more numbers. You have numbers on top and you have numbers along the bottom to divide. Savar? All right. So that's just another way that I kind of try to give you guys. Right. You don't have to worry about the last paragraph because that won't come up until 4.5. So you can ignore that other part and just stick with these first two parts. So don't worry about that for now. That's 4.5. Okay. All right, so now we're going to shift in. We covered the first 5 on your quiz, correct? Yes? Okay. Good. And now we're going to talk again about the multiplication rules and the, oops. So this is 4.3. So just a reminder, probability of A and B, that means they both have to happen. Right? So they both have to happen. That means that it's harder. It's harder for both things to happen. Right? And now say you go to a Warriors game, and at the halftime of the show they're like, you get this Steph Curry shirt if you can shoot a free throw. Is that easier, or is it easier for them to say, you have to shoot a free throw and you have to make a layup? Which one's harder? Just shooting the free throw, or we have to do the free throw and the layup? We have to do both, right? Because you have to do the first one and the second one. If you have to do both of them and, that lowers the probability of success because you have to do both. So and is harder because it's just that little overlap. You have to be successful at both things. So how do you find it? You multiply. If they're independent, you just multiply their probabilities. If they are dependent, then you multiply the probability of the first one. So then now the first one has happened. Now it's probably the second one given the first one has happened. And pretty much, if you kind of count on them being dependent and find those probabilities of the first one given the second one, or the second one given the first one has happened, you'll be in better shape. We'll go through a couple of examples later. Probability of getting at least one. All right, so this is the other thing that was key. Remember, either you have at least one sibling, or you have how many siblings? None. Right? you did at least one homework problem, or you did none. Right? So at least one and none are complements. Together they make 100%. We found the probabilities of those. So that means that you can find the probability of at least one by doing 1 minus probability of none of them. Because none is a lot easier to find. It's really easy to find the probability of all or find the probability of none, because there's only one way to find the probability of all. It's yes, yes, yes. Probability of none is also the easiest, it's easy to find because it's just no, 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 right? If you pick 3, no, no, no. If you pick 4, no, 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 no. How do you find the probability of none? Well, find the probability of the first one being a no, and the second one being a no, and the third one being a no. So it's the probability of no to the third power. So I'll go through that quiz problem with you guys. This is quiz problem 6. Did you guys get to quiz problem 6?
Yeah.
Did everyone get a chance to? Let's do this one first. So I feel like we kind of, well, maybe this one's easier. All right, no worries. How do you guys, who felt like 6 was easier than number 1? And who felt like number 1 was easier than number 6? Okay, so we'll do number 1 first. Okay. All right, so all were on time. So the probability that was on time is 0.716. Not on time, so this is quiz number 1, sorry, quiz problem number 1 from quiz 4.3. So then, not on time would be, well, 1 minus that, right? 1 minus 0.716. 0.284. Are we all good with that part? Okay. So if they're all on time, that means that was yes, and probably the first was on time, and the second was on time, yes, and the third one was on time. Right? We'll call these yeses. Yes. We'll call these ones no's. Is everyone okay with that? Can I shorten them to that? Okay. So yes and yes and yes is going to be probably yes, 0.716, and you're going to multiply it by itself 3 times. So you guys got for that, what did you guys get for that? Yeah. 367? Yeah. Good? Yeah.
On the test, do we have to do like P, all that?
Nope.
Okay.
So on the test, okay, so this is what you need to give me on the test. I need this part right here. Now, you could also write that as 0.716 to the third, that's fine. But you can't just give me the number without telling me how you got it. Good? All right. None were on time. Aha. So it means no one, no one, no. That means, what's probably that? It's a no. Sorry. Yeah, 0.284. And I want all 3 of them. So you can raise that to the third power. Good. So this is the bare minimum what I need on the exam is 0.284 to the third power. And what did you get when you did that?
0.023.
023. Good. 3 decimals is good? You good with that? At least 1 was on time. So that means 1 minus the probability that none. And I'm just going to take at least 1 and replace it with the word none. None what? None was on time. Oh, well, I found that. None was on time. 1 minus 0.023, 0.977. Okay, do you guys want 30 seconds to discuss with your neighbors? I think we do. Take 30 seconds.